We're surrounded by smart devices. I mean, everything from the thermostat on your wall to the parking sensor down the street. But have you ever stopped to wonder how they all talk to each other? Because it's not always your Wi-Fi. Today, we're going to pull back the curtain on two of the unsung heroes of the smart world. Z-Wave, the language of your smart home, and LoRaWAN, the network that's connecting entire cities.
Right, so just think about it for a second. Our world is just humming with this invisible communication. It's this huge ecosystem of devices, all quietly sending and receiving tiny bits of data to make our lives a little easier, a little safer, and a whole lot more efficient.
So, that brings us to the big question. How does all this stuff actually connect? It's not always your home Wi-Fi or Bluetooth. For a lot of these jobs, devices use these specialized communication languages. We call them protocols, and each one is designed for a very specific task. They are, without a doubt, the unsung heroes of this whole smart device revolution.
Okay, let's start with the network that's, closest to home. Literally. Z-Wave is kind of like the native language of your smart home, built from the ground up to manage all the gadgets and gizmos inside your house.
So, what is Z-Wave, really? Well, it's a communication protocol made specifically for home and building automation. We're not talking about streaming movies here. This is all about super reliable control and monitoring for your smart devices.
So instead of every single device having to connect directly to a central router, Z-Wave does something really clever. It creates this connected web, or what's called a mesh network. What that means is your smart devices can actually talk to each other, which makes the whole network stronger and way more reliable. Pretty cool, right? Let's dig into that a little more, because this mesh network thing is crucial. Every Z-Wave device can also act as a repeater, passing the signal along. So a signal from your main hub can literally hop from your smart lights to your thermostat to finally reach a sensor way out in the garage. It extends the network's range way beyond what a single router could ever do.
And here's another reason Z-Wave is so rock solid. It operates on a completely different frequency than your Wi-Fi and Bluetooth. While all those other devices are fighting for space on the super crowded 2.4 GHz band, Z-Wave gets its own private lane on the 800 to 900 MHz band. And that means way less interference and a much more stable connection for your smart home.
And finally, every Z-Wave network has a brain. This is your hub, or the controller. Think of it as a central command center that manages all the devices, lets you add new ones, and sets up all those cool automated rules that actually make your home smart.
So, what can you actually do with all this? Well, it's all about personal, home-level automation. We're talking about controlling your lights from your phone, getting an alert on your security system if a door opens, or having your thermostat adjust itself. It can even be the thing that opens your garage door as you pull into the driveway. It's that kind of stuff.
Okay, so now that we've got our heads wrapped around how Z-Wave connects our homes, let's zoom out, like way out. What about connecting an entire city or a huge industrial site? For that, you need a totally different kind of network, and that's where LoRaWAN comes into play. Yeah, if Z-Wave is built for meters, LoRaWAN is built for kilometers. It stands for Long-Range Wide Area Network, and the whole point is to let small, battery-powered devices send just tiny bits of data over very long distances. It's absolutely perfect for the massive Internet of Things.
The whole setup is different, too. It all starts with what are called end nodes. These are the thousands of tiny, low-power sensors out in the world. An air quality sensor on a lamppost or a water meter underground. They send their data to gateways, which act like bridges, just collecting all that information from the sensor. From that gateway, the data travels to a central network server. Think of this as the traffic cop. It makes sure devices are legit and routes all the data where it needs to go. And then finally, it hits an application server. That's where the data is actually processed and turned into something useful, like a real-time map of available parking spots in the city.
And the applications here are just huge. I mean, we're talking smart cities that can monitor pollution or make waste collection way more efficient. In farming, it's used for tracking livestock or checking soil conditions across massive fields. It's all about collecting these little drips of data from thousands of points over a huge area. So what we have here are these two really powerful protocols, Z-Wave and LoRaWAN, working in parallel. You've got one knitting together the fabric of our homes, and the other weaving this massive digital layer across our cities and industries.
So let's just break it down one last time, side by side. Z-Wave is all about short-range, personal automation, your home, your office. LoRaWAN, on the other hand, is built for the long haul. It's for connecting public and industrial IoT devices across kilometers, across entire cities. They're two completely different tools for two very different but equally important jobs in building our connected world.
And that kind of leaves us with a really fascinating question to think about, doesn't it?
We've seen these networks take over our homes and start to totally reshape our cities. So as this technology keeps growing and expanding, what's the next everyday object or system in your life that's just waiting to get connected? What's next?